Alright, in this problem I'm going to first show you what I absolutely would not do. Okay, I wouldn't do this, but some of you will be tempted to do it. So if you square this binomial, you might remember how to do it, or you might need to do it manually. But in any case, you're going to come out with x squared plus 6x plus 9, because you know that b is 2h and c is h squared. And so that's equal to 4. You subtract 4 from both sides, and you get x squared plus 6x plus 5 equals 0. Now you factor this, and you're looking for two things that multiply to 5, add to 6. Well, that's 5 and 1. Easy enough, you get x equals negative 5, negative 1. So take a minute. See if you can sort that out. Sort out what I did. I skipped a few steps, right, in terms of factoring the 5 times 1. In terms of setting x plus 5 equal to 0 and x plus 1 equal to 0. So if you don't see that, sort that out. See if you can get here. Okay, now that's absolutely what I would not do. I would not do that. And the reason I wouldn't do that is because I have the squared quantity alone. And when I have the squared quantity alone, I can just take the square root of both sides. So let me do that. Square root of both sides. X plus 3 equals plus or minus the square root of 4, which is 2. So now I'm going to subtract 3 from both sides, and I get x equals minus 3 plus or minus 2. And minus 3 plus 2 is minus 1. Minus 3 minus 2 is negative 5. And this is, I believe, much simpler. Especially, in this other one you got lucky and it could be factored easily. But what if it couldn't? Okay, so whenever you get the squared quantity alone, you should take the square root of both sides and solve quickly. Now looking at this next problem, you'll notice that I have a perfect square trinomial. If you don't see that, the b value, half of it is 3. And the c value, the square root of it, is also 3. And you have a 1 here. So that's your perfect square trinomial. You should recognize this is x plus 3 squared equals 4. And now I'm back to the same problem. So I get negative 1, negative 5. So the key here is to create a perfect square trinomial, or to have one. If you don't have one, to make it. And we call this process completing the square. Right? Making it so that it is a perfect square trinomial. If this is unfamiliar, or if you're trying to figure out how do you see all this, let's go back to example, where am I? At 10, I believe. Hopefully this is starting to look a little familiar, but if it's not, you might need a little more review, which is fine. Example 10. Is that 10? 10 and 11. You should start to recognize these and practice expanding x, things like x minus 1 squared, x minus 2 squared, x minus 3 squared. Noticing this is x squared minus 2x plus 1. That the c value is that number squared, that the b value is half as much. Because the more you do this, the better you are going to be creating these perfect square trinomials. Also, remembering back to the prior opener, remembering this rule, that c is half of b squared. So we can look at that. Is c is 9 half of b, which is 3 squared? Yes. If that's the case, we know our h value is half of b, hence our 3. Alright, we're going to continue, and we're going to start to work on completing the square. We're going to spend a lot of time completing the square to get you proficient at it.